Okay, so U prime, everyone should be very familiar already, correct? Yeah, U prime, you can straight away give me the answer already. Yeah, I don't have to. Shivani, can you give me what is the rate of change of 5x? Shivani, are you there?
Yeah. Can you hear me?
Yeah, definitely.
5.
5. Okay, how about a derivative of v prime?
E to the power negative 0.5x times negative 0.5.
Okay. You remember the product rule?
Yeah.
Yeah. Can you give me?
V times u prime plus
So wait, is this my v?
yeah,
So v u prime, what is my u prime?
5
Okay.
plus u times v prime. So
what is
5,
my u?
5x. Yeah, times e to the power negative 0.5x times negative 0.5.
Yeah. So now, in this case, you don't be too quick. You factorize first. So this is a common factor. 5 is the common factor. So we factorize it out. So if you take out the whole thing, you remember here is a times 1, okay? So I have 5 e to the power negative 0.5x, open bracket, 1 minus 0.5x. Am I right? Okay? Got it? Class, any issue on that? Okay, no. So part 1. Kevin, what to do with part 1?
Teacher, where you get 1?
Because this is times 1 when you expand. It's not where I get the 1, Kevin. If I have A minus AB, I want to factorize. I take out the A. Isn't there is a 1A here?
Oh, okay. See already.
Yeah, so have to be careful, lor. That's why I purposely put a times 1 there to remind myself that I have to put a 1 there. Okay? Can or not? Okay, Kevin, what is the answer for part 1?
I need to redo again because my rate of change function is wrong.
Okay, so now based on this rate of change function, you tell me what to do.
You sub in the 1 into the rate of change function.
Okay, so that means this is 5 e to the power negative 0.5. 1 minus 0.5, correct? So this will be 5 e to the power negative 0.5 times 0.5. So I have 2.5 e to the power negative 0.5. So may I know this is positive or negative? Thaddeus, is this value greater than 0 or less than 0? Thaddeus?
Yeah. Greater.
Greater than 0. Why you know it's greater than 0, Thaddeus?
Because it is 2.5 divided by e power square root e lah. And then both of them are positive.
Yeah, yes, that is the answer. Or you remember that e to the power anything always greater than 0.
Yeah.
Yeah, so also can. So you know it's positive. So it means that, so if I interpret the meaning, it means that at x equal to 1, fx is increasing or decreasing? Huh? Sarafina? Increasing or decreasing?
Increasing.
Yeah, because it's positive, because the rate is positive, correct? So fx is increasing. Because f prime 1 is more than 0. So that is how you interpret. Yeah. Although the question didn't say, but I add in to tell myself. Next time, if got question like that, I'm able to answer. So part 2, you are not going for exam, you are learning. So we will always learn more than what we. So f prime 3. Yeah. So I have 5 e to the power of negative 0.5 times 3. 1 minus 0.5 times 3. So I got 5 e to the power of negative 1.5. This is negative 0.5. So I got negative 2.5 e to the power negative 1.5. Okay, now I want to know this value is less than 0 or more than 0. Nicholas? Nicholas?
Yes. Hello.
Hello, hello, yes,
Yes.
I hear you. Tell me more than 0 or less than 0.
Less than 0.
Yeah, because e to the power of 1.5, negative 1.5 is always more than 0. Time negative, positive time negative, you got negative. So this is less than 0. So Nicholas, can you interpret for me? At
X
x,
equals 3, fx is decreasing because f prime 3 is less than 0.
thank you. Okay. So you can, I can write in word, I can write in the equation. So you have to know both. So this is called mixed language communication. Are you okay? So that means I know that at x equal to 1, the graph is going up. At x equal to 3, the graph is going down, right? So that is what I have in mind. Okay, now, can you do part B? Can I write this one over down there? So that I have more space for this one. Okay, how to do part B? Okay, how to do part B? Okay, can someone give me some idea how to do part B, Azif?
The dy dx, the function you equals to 0.
So f prime x
F
equal to 0, correct?
yes.
So I have 5 e to the power negative 0.5x times 1 minus 0.5x equal to 0. Okay, so next.
You I bring the e to the
No, don't bring. Don't bring. Don't bring. Yeah, don't bring. Because it's a product of two things, what? Correct? So why
yes.
you want to bring and make your life difficult?
Oh,
Am I right?
yes.
Yeah, so this one you will say no. No what?
No solution.
Yeah, no solution from this one. So the solution come from here, correct? So I have
Yes.
0.5x equal to 1. So my x equal to 1 divided by 0.5, I got 2.
2.
Okay, so now how am I going to state the nature? Okay, I will call someone else. Yeah, Cindy, how to get the nature of a stationary point?
Wait lah.
I wait. You must have your notes with you. How to get the nature of the stationary point?
Sub the x inside.
No, this is okay. This one is you get the y coordinate. So when x equal to 2, correct, nothing wrong. But I want to know the nature. Never mind, I will do what you say first. X equal to 2, correct? So I want to know the y coordinate. So I sub into fx. Okay, so I got 10 e to the power negative 1. So this is 10 over e. So I know this point, 2, 10 over e. So this is nature. Nature of a stationary point, that means you have to tell me whether it's a local maximum, local minimum, or horizontal inflection point, correct? So how am I going to determine the nature? That is what I mean. Gladys?
Draw the
I have to-
sign.
Yeah, yes. Sign diagram of what?
Of f prime x.
Yeah, so I have to draw the sign diagram of f prime x. So for f prime x, x can be any value, correct? And
Yes.
we know when x equal to 2, f prime x is 0, correct? So we mark here. And we can know the sign straight away from part 1 and part 2, correct?
Yes.
Yeah, Gladys? What is the
Yes.
sign for this region?
For negative.
Okay, negative. What is the sign for this region?
Positive.
Positive. So you look. So that means my fx graph for this part is going up, stationary, go down. Correct? So what do you call this point as? Is what?
Local maximum.
Yeah, it's a local maximum. So this skill you must remember. Okay, is it a global maximum also? Afterward we see, okay? It's a local maximum. Yeah. So you have to prove. Okay, so can we move to part C? Any issue on that? Can we move to part C?
Miss, you got the positive and negative from the red writing, right?
Yes. I don't have to test already because I have the answer from part A already. You get what I mean? Hello?
Yeah, I get it.
Yeah. So we do it that way. So sometimes when you do a certain question, correct, there's some guideline for you. So you just you don't have to repeat. Doesn't mean when I give you sign diagram, oh, okay, you draw the sign diagram for f prime x, then you have to test. No need, because you observe the answer from part A. So that is how you save your time. Okay, can we move to part C? Okay, for part C, I know that f double prime x is equal to, I have to differentiate f prime x, correct? Okay, so I must write down my f prime x first. So from the very beginning, just now, from part A, this is my f prime x. Yeah, this is my f prime x. So I'm going to go to that page. I'm going to write down is equal to 5 e to the power negative 0.5x, open bracket, 1 minus 0.5x. Okay, so you are going to repeat the products rule again. This is your u, and this is your v. Okay, everyone, those who haven't do, you can try. I'll give you some time to try. Okay, I hope you are ready. Okay, my u, okay, if for me, I will prefer to take my u as this one. I take my u as this so that I don't have to bring in the 5. So I take my u as this. So when I get my f double prime x, I remember to write a 5 outside first. So I don't have to keep factorizing it. Yeah. So v is equal to 1 minus 0.5x. Yeah. Okay. Hafiz, what is u prime?
E to the power of negative 0.5x times negative 0.5.
Okay. What is v prime?
Negative 1/2.
Okay. We just leave it as negative 0.5, okay? Yeah. So you get into the formula v. Please put in bracket u prime plus u v prime. Okay. So now you have a look at here. Common factor. Another common factor. So if I take out the whole thing, I have to remember this is a 1 here, right? So I take out. So when you do factorization, you have to be very, very careful. Negative 0.5. I have a 5 here, e to the power of negative 0.5x. Open bracket, 1 minus 0.5 x. Then here there is a 1. Right? So it becomes negative 2.5 e to the power of negative 0.5x. Open bracket, 2 minus 0.5x. Okay, the question say f double prime x equal to 0, correct? So I will write down negative 2.5 e to the power of negative 0.5x times 2 minus 0.5x equal to 0. Okay, so how am I going to solve this? Hao Shen? Hao Shen?
Yes.
Something times another thing equal to 0. So what should I do?
You put the negative 2.5 e to the power of negative 0.5 to the right side. So
Why must I put it to the right side? Hao Shen, are you in my class just now? Just now when we solved this. Hao Shen.
then you put another one into the right side.
Why I need to put the right side? I will say, Hao Shen, remember this. If I have two things,
Yeah, times
A-
0 becomes 0.
Yeah,
so
so-
like 1 equals to 0. Just
Ah,
left 1 there.
okay lah. So you tell me to write like that.
No, I one step slowly, ma.
Yeah lah, this is one step slowly already. What? Okay, so what should I write at the bottom of this one? Hao Shen?
Which one? Left one.
Left one,
Left one, no solution.
correct. No solution because of E,
Yes.
no solution. Okay, correct. You are right. Then the right one?
Right side is 0.5 equals 0. 2. Oh, 2. And
Some more?
then x equals to 1.
Hey,
No? Or 2
Boss.
or divide. Okay.
boss. Hello.
Yes.
Okay, so listen here carefully. I'm going to say something extra here. So we know that if f prime x equal to 0, this gives us the x coordinate of the stationary point of y equal to fx, correct? You must know whose stationary point. So if f double prime x equal to 0, this will give us the x coordinate of the, okay, I'm going to introduce inflection point. Of y equal to fx. If f double prime x equal to 0, it will give me the x coordinate of the stationary point of who? Of who? Of y equal to f prime x. So you see, because f double prime x is the rate of change of f prime x. Hello? So inflection point of this one, but stationary point of different thing. Look carefully. So later you will in chapter 3 you will draw the graph of f prime x as well. For this case, I will not. I will just let you know. So this is the inflection point. So when you talk about sketching the graph for this function, okay, you can use your graphic calculator to help you for this case. But exam, I will not ask. SAT one, no such thing. I just let you know a bit more. So we have our fx is equal to 5e to the power of 5x times e to the power of negative 0.5x, correct? So we know that as x approaches infinity, so we know there are two important points. One is the 2, the other one is the 4. Okay, so this is the highest point. Yeah, there is a turning point, correct? Maximum point. And as x tends toward infinity, may I know what happened to e to the power of negative 0.5x? Safwan.
The E approaches 1. E to the power of 0, so it is 1.
Hey, turn to infinity, ma. That is how you imagine e. I write in red. Imagine. Okay, e to the power of negative 0.5 times infinity, correct?
Yes.
So this is e to the power of negative infinity, correct?
Okay.
So this is 1 over e to the power of infinity, correct? So you approach what? You see, young people. You approach what? Thank you. Let your imagination run wild. So 5x tends to infinity, but my fx, which is 5x times e to the power of negative 0.5x, will tends toward what? Tends toward what?
0.
Safwan. Yeah, 0, because this is 0, ma? Right? So as x tends toward negative infinity. Okay, Thaddeus. What happened to e to the power of negative 0.5x?
Infinity.
Infinity. What happened to 5x?
Infinity. Negative infinity.
Thank you. So therefore, my fx will tend toward negative times positive, negative infinity. So the graph go like that. So you see the graph go concave, but here have to change to convex. If not, it won't be able to approach 0. So that is the graph that you have. Are you okay? So you see this question is actually you have done everything. Yeah. So you just need to learn how to differentiate, then how to apply it. Can or not?
Miss, can you go
Yes?
to the previous page, please?
Yeah, sure.
Thank you.
Okay. Okay. So what is inflection point? Your friend asked. Okay, what is inflection point? You see, this part along here, if I draw a tangent at this part, don't you find that the tangent at here is the steepest? So the inflection point here means that here it means, okay, fx at x equal to 4. Fx is decreasing at the fastest rate. So that is the meaning of non-horizontal inflection point. Okay, if I name this A, name this B, and name this part as C, correct? So A to B, fx is decreasing. Decreasing means going down at increasing rate, because it becomes steeper. Then from B to C, fx is decreasing with decreasing rate, because it becomes less steep. Done. So that is, so this point is when this one changes. Got it? The decreasing is showing the graph is going down. So that is called the inflection point. So at that point, if it's going down at the fastest rate. So that is what you mean by inflection point for a given function. So I have to mention the function. I have to say is fx or f prime x. Okay? So now at least you have some idea of what is stationary point, what is inflection point. So you can determine the rate by looking at the graph. Yes, you can determine the rate by looking at the graph. Okay, so any more question? So you see from this question itself, a simple question like that, I can teach you a lot of things. So it depends on how I want to approach the thing. Yeah. So anyone got issue on 2F? Do you have issue on 2F? Any question on 2F that you like Miss Do to explain to you?
Yes.
Yes, which one?
6C2.
Okay. 2F, 6C2.
Yeah.
Okay, y equal to 8 times 10 to the power of x. So what I need to do is 8, the 10 I change to e to the power of ln 10. Are you okay?
Yeah.
Or if I don't want, I will use this formula. So this one will be dy dx.
Miss, why can suddenly change like that one?
It's not suddenly change like that. Any number can be written as e to the power of ln a. Okay. If you, I prove it to you, okay? You are not satisfied if I didn't prove it to you. Why? How this formula come about? Okay, I prove it to you. Okay, 10. Okay, a to the power of n. I let it be k. Can or not?
Okay.
So now what I do is I take ln on both sides. Can or not?
Okay.
So now I have n ln a equal to ln k. So what is my n?
K.
Ln k, wait, divide by ln A. Cannot prove like that. No, I cannot prove like I don't do like that. I don't do like that. Don't do like that. No. I don't do this way. Sorry, don't do it this way. I write it this way. Look, I write it this way. My A why I put A to the power? Okay, never mind. No. I'm wrong. I want to write this as this form. Am I right? So what I do is, hold on. Okay. I do it like that. The other way now. Okay. I put e to the power of ln x equal to y. Okay. I do it like that. So both sides I take ln. Right?
Yes.
So this one I can bring in front, correct?
Yeah.
Okay. So what is ln e? Ln e is 1, ma?
Oh yeah. Only one.
Okay, so ln x equal to ln y, correct? So what can you say? Therefore, x equal to y. So therefore, e to the power of ln x equal to x.
Wow. Okay.
So that is the formula that derived from here. I forgot already how to derive. So yeah. So you see, even I forgot how to derive, but when I start with that one, it cannot work. I start with another way. You see or not? That is called try. Okay. So this is a very important formula we have to remember. Yeah. So your dy dx will be equal to E8. Copy down the whole thing. Then time by ln 10. That's it. So, and this one is the same as this. So I can write here as, that's it. Okay, class, satisfied?
Miss, for this case, cannot use product rule.
How to use product rule? This is a number. Why you use product rule, young man?
Oh,
Oh,
okay.
yeah. You use product rule, you're wasting your time, nah? A number times by a variable, you don't use product rule one. Because it's a number. Even they put a multiply doesn't mean you have to use product rule. Get me?
Okay.
Okay, good. At least you ask. Then I can give you the reason why. Okay, any more? Should be quite okay, right? Yep. No more, huh? Okay. So thank you, class. We'll see you tomorrow.
Thank you, Miss.
Thank you, Miss.
Thank you, miss.
Thank you, Miss.
Thank you, miss.